Good evening, sir.
Hey, Josh, how you doing?
Doing fine, sir. How about you?
Could have been worse. I'm giving thanks.
Awesome. Um, just
Go
want to
ahead.
give you a heads up, I'm catching up with the videos. I was kind of busy over the weekend doing other uh, courses.
Mhm,
So I'm 2 videos behind, so just a heads up. So
mhm,
if I'm not too, answering right now, just
mhm.
that's the reason. Okay.
No problem.
All right, cool. Thank you.
Good evening.
Good evening.
Good evening.
Good evening.
All right, so I gave you guys an additional homework question. Anybody did that question?
In order for us to get information on performance, guarantee them with priests and with good people.
Hello, 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 hello.
And now we're bounty hunter jobs.
Evening again. No, sir. Wasn't at the last class.
All right, but you see the question, all right? You see the question? Talk to me now, guys.
The question in the group.
Right, right. So do me a favor. Let us just start that question now, please. Yeah, man. Just start that question now for me, please, because I'm just going to do a revision on this question and the double integration. And then come Wednesday, we finish off the topic and then we call it a day. So see if you can start this question for me, please. You all got a copy of the question. Start that question for me, please. Let me see how I can copy image. Let me see. Oh, I can do this.
You hear me, sir?
I'm hearing you now.
Oh. Yes, sir. I won't be able to right now. I'm currently still at work and I'm kind of tied up, so I'm just listening.
All right, then no problem. Thanks for the notification. All right, see the question there? Give it a very good attempt because all I'm doing today, I have one topic left, just one topic left. that I plan to do on Wednesday, God's willing. Today is just Lagrange double integration. So we do a Lagrange now, then a double integration, and then we just call it a day. Call it a day. So please start working for me. I want everybody to give an attempt to this question. Big up on yourself.
Evening, sir. Evening, everyone.
Good evening, sir. Sir, what's up?
Sir,
And
Yes, sir.
they have firearms training, which made them dangerous to the surveillance.
I hear you, Chef.
what's this question?
Yeah, man, I actually sent this question in the group from last week as an extra question that I wanted to do. So just checking to see if you have done it. You didn't do it? Did you?
I didn't get a chance, sir.
All right, no problem. So let's work on it now quickly for me, please.
Good afternoon.
All right. Anybody finish? Hmm?
Sir, I am somehow, sorry for not responding earlier. I am stuck at step 2.
Okay.
Couldn't
What did,
read it all.
what did you get for? What did you get for alpha?
Alpha.
Lambda, sorry. Sorry. What did you get for X in terms of lambda?
That's where I am.
That's step 1 then.
So I'm about to move to step 2.
Mm.
And I'm not sure how to make it the term because I currently have 1 minus 2, which would be subject to 2x plus 2y, and then we would have 2x equal to lambda x and 2y equal to lambda y. But then I'm not sure
Say that again.
why. So what again? Not sure?
Wait a while ago.
I said a lot of things.
So wait a while ago.
Huh?
Wait a while ago. Start from the scratch again.
So I have 1 minus 2, which would be subject to 2x plus 2y equals 0. Then I put that in terms of lambda, or I think that's what I'm doing. 2x equal to lambda x, and I have 2y equal to lambda y. Where I have the 1 minus 2, I'm not sure where to go with that part of that.
That was the first information that the was had, that they got might have been using something prior to simply by the way you framed this.
That's not where I want it to be. Anybody else reach anywhere?
Yeah, me stuck as well, you know, sir.
I'm working. I mean, I really get that topic here, real. I don't get it.
Sir, Mr. Career after me is stuck, sir.
All right,
I
hold on
think
a
I'm
minute.
stuck because the previous questions or the examples that we're accustomed to would have the x square versus this only have one x.
Remember, sir, so we can use previous example only, okay? Think outside the box.
Every yellow here.
No, Master Sir, sir, we cannot use previous example only. We have to think outside the box, but
Where you say they get SNL one
That's
man?
the reason me I go slow for reason it out.
Where they get you say get SNL 1 minus 2 lambda x, you equate that to 0, and 2 minus 2 lambda y equate to 0 again.
Never that me say, but you're one sound sensible.
Me I try to figure out what sir have an in last example and see if me can do it, but me not think I get it that
If
time.
I use the last example, you
That's
have
where-
to use the steps.
Yeah, me know, me not really say use the last, but me just try to figure it out and put it in a context.
that's where me, that's what I get to, Pastor. But for some reason,
Where you get?
2 lambda x minus 1 equals 0.
2 lambda x, okay.
I same thing now, same thing around.
Yeah.
I don't know what else to say to you about this topic, though. I'm wondering if I did that bad a job in teaching the topic, but I don't know what else to say to you.
So I don't think anything for me, I just been to the classes. I'm gonna sketch piece and stuff and I try to get.
Searching for a way to shut the drug boss down. Detectives knew that murder victim Iman Walker was with Jones before.
All right. What's the first step again?
Differentiate.
Differentiate the like terms. Yeah.
What's the second step?
We solve for x and y in terms of lambda.
What next?
Yeah, substitute the what they value them where you get for x and y in the given constraint where you have.
Yeah.
So give me the value of x. Based on what you do, what's the value of x? Somebody must be able.
So
All
I
right.
get 0.5 over lambda. Or is that
Wait, sorry, I didn't hear it. Say it again.
0.5 divided by lambda?
What do you get for y?
1 divided by lambda.
That is correct. That one is correct. But the first one is not correct. It says 0.5 divided by lambda. No.
So no 5 over 2.
The other one would be 2 over lambda.
1 over 2 lambda is that
Right. 1 over 2 lambda is not 0.5 divided by lambda.
1 over 2. Oh,
It's supposed to be 1 over 2 lambda. Supposed to be 1 over 2 lambda. All right. What next?
Hold on.
Talk to me now.
Formula now, so the constraint. So you have to go square it, put it back in the equation and say like 1/2 lambda square plus we'll have 1 lambda square.
Um, mm, mm. Um, all right. So
After we solve for x, him say him get 1/2 lambda, right?
mhm.
May I ask if the next step wouldn't for the x wouldn't be to put it into the equation for the constraint?
I think we have to find lambda.
Lambda, okay, yeah. Find lambda.
I did a bad job in teaching the topic.
X minus 1/2 lambda. Why would that be 1 over lambda? Right? 1 over lambda.
Or is it that it's coming up to the end of the semester and then it just tune me out?
Sir, nothing like that, sir. Not a thing.
Nothing like that, so for real, nothing like that.
I try to figure it out. So when you say you get x to be 1/2 lambda and y to be 1 over lambda, you say? That is what you say it's right, sir?
Yeah.
Mhm.
And then when you get those, so it's second part, something I say if you solve for x and y. That is x and y, we have that already. So we're not gonna put it in the equation and say 1/2 lambda square plus 1 over lambda square equal,
All right then. Press
equal
pause
1.
1 minute. Press pause. Okay. Yes, you are correct, but press pause. So you're gone ahead of me now. So
Oh,
but based on what I hear, that's what you're going to be doing. So let us just go through it now. Do you agree with my x equals 2 lambda x and my 2 is equals to 2 lambda y?
yes, sir.
Yes, sir.
Oh, come on. Why every time I start a page, I don't include my blank page? All right. So do you agree with that what I have on board so far?
Yes, sir.
I want to hear from everybody now.
Yes, sir. Yes, sir.
Afternoon.
Yes, sir.
All right. So therefore, I'm gonna ask the question one more time. Do you agree with what I have on the board?
Agree, sir.
Well, I disagree with you.
But I disagree, sir.
Because when I differentiate x, I don't get x, I get 1.
Oh,
But sir, when we said earlier, you never tell we for right or wrong, and we have something different. So,
What?
sir, nobody play no mind game this evening, sir.
I'm not playing any games at all. Any game you want to play for, go lay down and sleep. Trust me. But
I get through that one there. I get through that one there.
I catch with that one there. All right, good. Come in and no want to hustling now. Hungry now. Yeah, them chaos. Let's go.
I'm tired.
So we have 1 equals 2 lambda x. So therefore, we're gonna have, you know what? Let me just put it like this. 2 is equals to 2 lambda y. I'm gonna divide both sides by 2 lambda.
Get rid of the x.
Right, I'm gonna divide both sides by 2 lambda.
X.
So this cancel this cancel this. So we have x now to be equals to 1 over 2 lambda. Agreed?
Agreed.
And then now y is going to be equal. So I'm going to call this 1 over lambda because I'm going to cancel out that 2 and this 2. So we're going to have 1 over lambda.
Yeah.
Agreed?
Agreed.
All right. Let's continue. And then now, what's next? What's next?
Sir.
Hmm.
Doesn't make sense, sir. Find what is lambda.
No, you can't. You can't yet. Because you have to then substitute into the constraint to find what is lambda.
All right.
So constraint is going to be equals to x squared plus y squared is equals to 1. So x is going to be 1 over 2 lambda all squared plus 1 over lambda all squared is equals to 1. That is 1 squared is 1, 2 lambda squared is 4. 2 lambda is 4 lambda squared. 1 squared is 1. Lambda squared is going to be lambda squared is equals to 1. What's the LCM?
4 lambda square.
Very good. And
Right.
4 lambda squared into 4 lambda squared goes?
1
And 1 times 1 is 1. How many
Mhm.
times can lambda squared go into 4 lambda squared?
4.
And
4
4 times 1?
4.
4 lambda, 4,
And this
4.
is going to be equals to 1. 1 over 1 is the same thing as 1, don't?
Yeah.
4 plus 1 is going to be equals to 5, don't?
Yeah.
So that's
That's
5 over 4
lambda.
lambda squared is equals to 1 over 1. 2 fractions separated by an equal sign always.
Cross multiply.
Cross multiply. Mhm.
So we're going to have 5 is equals to 4 lambda squared. Divide both sides by 4. Bam, bam. So we
Lambda
have 5
square.
over 4 is equals to lambda squared.
Yeah.
If I take the square root of both sides, it implies that lambda is equals to plus or minus the root of 5 over 4, don't it?
Definitely.
Over 4. 5 over 4. And we have 2.
I'm going to do it this way. I'm going to do it this way. Watch this. The root of 5 over 4 is the same thing as the root of 5 divided by the root of 4. That's what the root of 5 over 4 is. The root of 5 over 4 is the same thing as the root of 5 divided by the root of 4. What's the root of 4?
2.
2. So we end up now with plus or minus the root of 5 over 2.
Mm-hmm.
I'm going to tell you why I do it like that. Because now that I have the values of lambda, what do I do?
Substitute it in the 1 equal 2 lambda x.
No, man, I substitute it right here to find the value of x.
Already. Do it.
Come on, that one, sir. That one, yes, that
right. You remember, so we'll find the value of x rather than the value of y. So now that we have the value of lambda, we want to
Critical point.
remember, it says not a critical point, you know.
Yeah.
So I'm going to recall something here for you. So recall
X equal
X is equals to 1 over 2 lambda.
Sir, don't stop here. Say we don't, it's not a critical point.
No, it appears to be critical point, but it's not a critical point question.
Okay.
Y is equals to 1 over lambda. I want to recall it because I don't want to be back to scrolling up and down, up and down, up and down. All right. So there's a reason why I call this. What?
Some at me.
Sir, hold a second, pause. Sir,
I'm hearing you, my love. I've paused. That's why I'm scrolling back up.
just put the question there. Right where you cross multiply, right?
Mm-hmm.
You're multiplying 5 by 1, 1 by 4 lambda squared.
Yes, bad.
We end up with 5 over 4.
Because I'm dividing both sides by 4 to get lambda squared. Yes, no?
So you can write that down. Let me see where I thought. So after we cross multiply, then we divide both sides by 4.
Yeah, 4 lambda squared. I need to
Okay.
find the value of lambda.
Okay.
So I have to isolate the 4 from it.
I see it now.
Okay, good job.
Thanks.
No problem. Any other question? Anybody else?
Not for me, no.
Where do I go? Where do I go? Should I continue? Should I re-explain something? Somebody talk to me now. Well, I talk to myself, you know.
No, I said not for me.
No. I heard you. But there are others in the class, so you responded to my question. I'm asking, is there any other question?
No from me, sir.
No, sir.
Okay, all right. All right. So let's move on. So now they have the value of lambda, or the values of lambda. I need to substitute. So I'm going to substitute here to give me x is equals to 1 over lambda is, I'm using, all right. Using positive the root of 5 over 2. Follow me? I'm telling you which other values I'm using. So I'm going to have x to be equals to 1 over 2 times the root of 5 divided by 2. Can you understand why I did what I did right there? So because this is 2 over 1, this 2 cancels that 2. So I'm going to be left with 1 over root of 5, don't it? Hello? Somebody?
Yes, sir.
All right. And y is going to be equals to 1 over lambda, but lambda is the root of 5 over 2. Hey, look at what I'm doing. I'm rationalizing. So I'm going to multiply by 2. That means I need to multiply up here so by 2. So me multiplying the numerator by 2 and the denominator by 2 is as if I'm multiplying by what number? Yeah, I'm rationalizing, but I'm saying I'm going to multiply the denominator by, is as if I'm multiplying by what? Hello.
Multiplying by 1. That
Very
is
good.
2 over 2.
Very good. As if I multiply by 1. And you know that 1 is a multiplicative identity. So if I multiply by 1, I'm really not changing it. It's just a rationalization that I'm doing. All right? When I do that, this happens. This 2 cancels this 2. So I'm going to have now this going to be 2 over the root of 5, don't?
Definitely.
Make sense?
Yeah.
All right. So using negative the root of 5 over 2, I'm going to pause right there and ask you to do that one for me, please. I want to make sure that you're following. Do that one for me, please. Or those two. Question almost done. Oh, stay.
Sir.
Mhm.
I'm getting the same answer, but negatives.
Getting the same answer but negatives?
With negatives, yeah. Negative.
It is positive. If it's possible, don't you say we do the question like that and we get the same thing like the last question we get 2 and 2 and negative 16 and negative 16, don't it?
Yeah.
So it's possible. Let me work it for you. All right. Okay, that's where I'm at. I am at I just lost my thought a while ago. So this is going to be 1 over 2 times negative the root of 5 over 2. The 2's cancel. So yes, it's going to give me negative 1 over the root of 5. And then this one, y is going to be 1 over lambda. Lambda is what's wrong with me? Lambda is what is lambda again? Negative 5 over 2. Negative 5 over 2. No, the root of negative 5 over 2. And similarly, like I did in the last one, if I multiply down here by 2, I'll have to multiply up here by 2, as if I'm multiplying by 1. And then this is going to give me, this cancels this, negative 2 over the root of 5. So yes, get the same answer, but it's just a negative. So what do we do next with this?
So now we're substituting the f of x on the function.
All right, f of xy is equal to what again? X plus 2y? X plus 2y. So I'm gonna have x plus 2y. So what I'm gonna have f of 1 over the root of 5, comma.
Sorry, not
Two.
-1. -1 over the root.
I'm using the first value first.
Oh, okay.
It's going to be equal to x, which is 1 over the root of 5 plus 2 times y. What is y again? 2 over the root of 5. So the question worked out nicely.
2 over the root of 5.
So 2 times 2 to the root of 5. Two times the 2 to the root of 5. 1 minute, please.
Plug it in the calculator now, sir.
No, well, you go ahead and put it in your calculator and then you can confirm with me. That's 2 over 1. I'm going to get 4 over the root of 5. The LCM is the root of 5. Root of 5 and the root of 5 is 1. So you're going to have 1 plus 4, which is equal to 5 over the root of 5.
Oh, root of 5 to be equal to the root of 5. Minus root of 5.
They say one. The answer in decimal, sir.
Yeah, you can give me the root of 5 over 5. Yeah, you can give me the. Yeah, what you get for that one?
Working maximum. Root of 5.
You get 2.23, 2.24.
Two twos for down. -1 -4 is -5. Will that work out for you? Understand? On the field.
Agreed, sir. Agreed.
All right, let me ask one question.
Sure.
So,
You just answer me or anything?
talk, sure.
For the 2/1 is just for calculation purposes, right?
Yes, my lord. Yes.
All right, cool.
So the way I do it, I want to show you that the 2 is only multiplying the numerator, not the denominator, or both.
Okay.
Mhm. Let me ask you. Now that you've seen me work through the question with you, do you think it's difficult?
With
Mm?
reasoning ability a little. With the steps, not so much.
All right. Let us talk through. Let us talk through something a little bit here. Mari, all right, Papa?
Yes, sir. I'm good.
Okay. Are you understanding?
Yes, sir.
Good. Simon, how is the
Here, sir.
understanding?
Yeah, sir.
No, I mean, like what I yes, the comment, like on a piece of. Prozzy, how you stay? Oh, sorry. You did say that you are distracted at work. All right, I will leave you alone. Utterly, how is stay?
I am getting there, understanding more and more each.
Okay. You know, what I was say a while ago, I sleeping,
No.
I'm sleeping.
No.
All right. All right. So let us just walk through this question again. Because, to be honest with you guys, I expect one of this. Mark, you You may very well go into the exam and you may very well not do this question because you may very well see another question for similar marks that you may be stronger at. But you also may find this question for, say, for example, for 10 marks, and the other two parts of the question for this question for 20 marks, or the other part for 20 marks. You can angle and triangle. So I'm saying to you, what must be done is that you can't go in an exam and say, I'm not going to do this. Learn it because you don't know what you have to go rely on. So let me just walk it through. Let me walk it through with you. And walk with me, walk along. We're walking side by side. Determine the maximum and the minimum value of f comma xy, which is equal to 2 plus 2y, subject to the constraint x squared plus y squared equals 1. All right, 1 second, please. So the first thing we do is to differentiate corresponding terms. The x term will be differentiated with the x term in the constraints. And in the constraint, we're going to include our lambda. Similarly, the y term is going to be differentiated with the corresponding y term, and we're going to include our lambda. What am I saying is the differential of x is 1, right here, so. And jump over to the constraint, the differential of x squared is going to be 2x. But because we're talking about the constraint, we're going to put 2 lambda x. Lambda is there going to represent my constraint. All right. Similarly, I'm differentiating my y. So the differential of 2y is going to be equal to 2, which is right here. So this 2 right here. So, and the differentiation of the corresponding term, y squared, is going to be 2 lambda y. See here, so 2 lambda y. Then I'm going to work and make x the subject of the formula by dividing both sides by 2 lambda. And divide both sides by 2 lambda, these 2 lambdas cancel, so it isolated the x. So I have x to stand alone. But what it gave me is 1 over 2 lambda. That's going to be my x value. Similarly, I'm dividing both sides by 2 lambda so that I can cancel these and isolate the y alone on this side. So y is going to be equal to 2 divided by 2 is a common term, so I can cancel those. So I'm going to get 1 over lambda. So I'm going to have 1 over lambda. So now I have my x and y values in terms of lambda. I have my x and y values in terms of lambda. What I'm going to be doing next is substitute those constraints, the values of x and y in the constraints. So therefore, I'm going to have 1 over 2 lambda squared plus 1 over lambda squared, and is equal to 1. What's the aim of that step, sir? So that we can evaluate lambda. So that we can evaluate lambda. When we do that, we're going to square 1 over 2 lambda squared plus 1 over lambda all square. And when you're squaring something like that, 1 square is 1. 2 lambda times 2 lambda is 4 lambda squared. So that's why I have a 4 lambda squared here. 1 squared is 1. And lambda all squared going to lambda times lambda, which is lambda squared. What's the LCM between 4 lambda squared and lambda squared is going to be 4 lambda squared. Boy was out of the ballpark with that hit. How many times can 4 lambda squared go into 4 lambda squared? 1 time. 1 times this one is this one. How many times can lambda squared go into 4 lambda squared? 4 times. And 4 times 1 is 4. Which of course is equals to 1 over 1. 1 plus 4 is 5 over 4 lambda squared is equals to 1 over 1. I'm going to cross multiply. Once I have 2 fractions separated by an equal sign, I cross multiply. That's a good hint. Whenever you have 2 fractions separated by an equal sign, you cross multiply. In cross multiplying, 5 times 1 is 5. Is 5 here, so. and 4 times lambda squared. Remember, these squares cancel out already, you know. So it's just the square that I have done. So 4 times lambda squared. Is it before lambda squared? No, sorry. I'm dividing both sides by right here. Sorry, I went here and I went back up here. No. So I'm cross multiplying. 5 times 1 is this 5, and 4 lambda squared times 1 is 4 lambda squared. And then I'm going to divide both sides by 4 to isolate the lambda. So I'm going to have lambda squared is equals to 5 over 4. Just writing that a little neater. Lambda squared is equals to 5 over 4. To find the value of lambda, I'll have to divide, I'd have to find the square root of both sides. I have to find the square root of both sides. Now, in finding the square root of a number, I always take into consideration the positive root as well as the negative root. Always. Always take into consideration the positive root as well as the negative root. So therefore, the root of lambda, the root of lambda squared is when it just gives me lambda and equals to the root of 5 over 4. But remember, I said to you that the root of 5 over 4 is the same thing as the root of 5 divided by the root of 4. Why did it like that, sir? Because I recognize that 4 is a perfect square. So when I find the square root of 4, I'm going to get 2. I'm going to get 2. Sir, you just said what I'm going to get plus or minus 2. Yeah, but see the plus or minus here already. The plus or minus is here already, you know, so I don't need to put it again. So I'm going to have the root of 5 over the root of 2. So I'm going to recall more the values. I'm going to recall my x in terms of lambda. I'm going to recall my x in terms of lambda. And what I do there is substitute the values for lambda into my x. And that is going to be 1 divided by 2 times lambda. And lambda is the root of 5 over 2. The 2's cancel, so that's going to have 1 over the root of 5. This is using this first term. So each term I was substituting to my x and y. So I now need to use the same term, the root of 5 over 2, and substitute it into the y value. In substituting, I'm going to get 1 over the root of 5 divided by the root of 2. So I'm rationalizing. So what I'm going to have is this 2 canceling this 2, and this 2 remaining in the numerator. Recognizing that I have not changed anything, because when I multiply by the root of 2 divided by the root of 2, is as if I'm multiplying by 1, because the root of 2 divided by the root of 2 is indeed 1. So I'm really not changing anything. And I'm going to end up with 2 over the root of 5. And similarly, won't do these, but similarly, when you do this stuff, you get the same values, just that they are negative. I end up with my coordinates now. These 2 are married, so I'm going to put 1 over the root of 5, comma 2 over the root of 5, and the other 2 are married. Negative 1 over the root of 5, comma negative 2 over the root of 5. And all we do is just go back to our original function. And we're going to substitute those values there into my original. And I'm going to get 1 over the root of 5 plus 2 times 2 to the root of 5. Asking love the question, sir, why did you put this over 1 again? Just to show that when I'm multiplying, I'm not cross multiplying here. So I can't cross multiply beside a multiplication sign. No, that doesn't make sense. So always put it over 1, the whole number, if you have something like that. So you recognize that it's 2 times 2 and it's 1 times the root of 5. So 1 times the root of 5 is merely the root of 5. And 2 times 2 is 4. The LCM will be the root of 5.
You say always put it over 1. If we
The
don't,
whole number. The whole number, yeah.
if we don't, that's a problem. We'll lose marks or something.
You won't lose mark, it's just to help you.
Okay.
To know, say, is this 2 is being multiplying, will be multiplying just the numerator. and the numerator alone. Follow me?
Yes, sir.
And then now, this one works out nicely because again, have 4 over the root of 5. The LCM is going to be the root of 5. And once the LCMs of the denominators are the same, you just go ahead and add the numerator and put back the denominator. So 1 plus 4 is 5. So I'm going to have 5 over the root of 5. Chavoy says 2.2 for search. All right, that's a whole lot. And then similarly, I'm going to use the other point. All right, now you guys to breathe.
So when is our last class?
Our last class will be on Friday.
Okay.
Oh, I hear how sad you feel.
No, I was
Yeah,
hoping it's a Wednesday.
you're gonna try and be nice. Just try.
Right about now, the trying tired, much less me. The question
Yeah,
that
I know.
was baffled for the mid semester. Can you go through it, please?
I will. I don't know the exam papers. I am trying to mark them off. I'm marking actually. But I'm trying to mark them off for Wednesday's class so we can spend some time and go through that. I won't read now. I'll go through it in Wednesday's class.
What
Because
about
I'm
your
in mark.
sleep when we do?
No, so not drop asleep on you. I was that was Saturday. No man, Saturday
Or you just decide to ignore me? Which one?
no, I got distracted. No man, I was here because actually I was in the kitchen when a student, remind me, yo, what on? I'm gonna say, Jesus, time run out because when I got home, it was way before 8 o'clock. So when me hear 8 o'clock coming shut. So the computer was giving me a little problem to come up. So that's why it took so long for me to upload the screen. So I went back to do what I was doing. And it's long after I said Rockstone, them finish. Because when I checked it and I didn't see anything at 10:30, I said, all right, make them go on with them stuff. And then I was up, man. I was very much up and about. All right.
Sir, do you have a copy of a recent paper?
You know where you can find that? Go to the library resources. Over there, Lord Jesus.
Well, let me double check. As I don't think I think I checked for color. I don't think I'd check for color too for you, but I'll check and tell you.
All right, check again and let me know. 4702. Check again and let me know.
Yeah.
Man, we supposed to over there, because I think this course was offered in summer last year. So there should be a paper for matter of fact, this course, if I'm not mistaken, was offered second semester and then again offered in the summer. If I'm not mistaken. All right. So therefore the bigger one is going to be the maximum, of course, the smaller one is going to be the minimum. So this is what happens right there. Let me know if you're good. Are you okay?
Yes, sir. Yes, sir.
Good.
Oh, sir.
Uh-huh.
So I didn't get a chance to upload my
Don't worry about it. I've downloaded them already. I'll do the uploads thereafter. Don't worry about it.
Oh,
We're
yes,
not
yeah.
gonna-
I share it here.
I know, I saw it. I've downloaded the paper already.
All right, cool, sir.
Yeah, matter of fact, from the list here. Right, I will talk to them two students here because I've downloaded. Let me just check to see my thing. Yes, I have that one. No, but I know so. Oh, okay, okay. I know what happened. I know what happened. All right. I was gonna. All right. Let me give it to you because I don't want you to think that I'm lazy.
Sorry,
Yes, please.
I'm only seeing 2017 as a recent. The other is 09.
All right. Oh, Jesus. I mean, I have it to know. Because I think the last two sets of exam was face to face.
You don't know where to get it?
To be honest with you, it will be easier for you to get the paper than for me to get it. So that's all. All
Okay.
right, I'm having a. I'll try no, but you can try as well. But I'll try. I'll try.
I'm gonna
Mhm. All right. So it's one of two things. I can either end the class here, or I can just give you a teaser in terms of a double integration question, just one. I will just work it up until the end of the class. Which is it?
in the class here. Give
Me
us
know that
your homework.
me know that
We do it.
I said, me say I was holding my breath.
Yeah, but brain clock out from 3 o'clock today.
say,
And
me
now it's
no say that they go say. Me know that they go say something. I was holding my breath to say, okay, she not talk, Corp and talk, no man, me suffocate. You've never failed. All right, so I can end here, it's not a problem. Because they would have started. Anybody watch a video I sent to you with the integration, double integration? It's a 2-minute video. It's a
No.
2-minute video. I watch
You
longer
mean the
TikTok.
one in the WhatsApp?
Yeah.
Yeah, watch that.
Okay, because I watch longer TikTok than that. All right. So all that is left really is my differential equations. My differential equations that are left that I'm not going to spend a whole lot of time on. And then just to do one or two more questions on double integration. The truth is, I wanted to just do double integration tonight, but based on the request, I don't even know who requested it. Oh, I was asking if you did my assignment, and then now I recognize that there were some questions. I was feeling very guilty that maybe I didn't teach a topic okay-ish. So that's why you weren't getting it. I hear one or two say, sir, it's not you, man. Everything good. Just say it again, Aston. Oh, you need to mute Aston.
That's
So,
not me.
oh, utterly, you need to mute. Thanks. Oh,
I didn't hear what you say.
no, I think your mic was open and you were talking in the background.
Not me.
Why are you looking at me with those big eyes of yours, Aston? Don't look for me. All right, let's go. The on Wednesday's class. Wednesday is yeah, for Wednesday, we're just going to spend some time looking at some more differentiation. I'm going to see if I can find another video. So there's another form to the double integration. Well, when I say another form, it's just the indefinite one. So I gave an example of a definite. I just need to do an indefinite one with you. And just do some of that. So truth be told, Friday's class is just really a top up Oh, I know what I can do on Friday. I can spend the time to just go through the mid-semester. I think I'll hopefully I can finish marking. I'm actually trying to mark off another set of mid-semester. Hopefully I can finish marking by Wednesday. If not Wednesday, I'll definitely mark up the papers by Friday, so we can just spend the time in class on Friday to just go through that mid-semester. And if you find any questions on any past paper that you want us to run through, we can just jolly well just run through those. And then we'll finish with a bid you farewell. You have 1 week to do your stuff. If you need help, shout at me. Don't shout too loud though. And then we're good to go. Just go into the exam and just maths it out. The exam is not difficult. Don't ask me how I know. I'm going to tell you why I said the exam is not difficult. I don't know how I do it, but skillfully I was able to cover the syllabus. We covered the syllabus. And if you were to ask me in this block scheduling dispensation, I never had a challenge covering the syllabus at all. I got enough time to cover the syllabus, and you guys are very receptive in doing this stuff. The only challenges I have, and I'm not going to call a name because I don't know, but is it true? Some of them they go a country, very far country over this weekend, and now go rubbing out. But my Educasoft still needs to be completed. Still needs to be completed. All right? Some of you are done, and some of you are on your way. Some of you are pussyfooting around it. Students, me not tarry with my exam paper them. Me want to enjoy my summer this year. So me want, as exam done, me in a summer mood. Summer mood. Me really very tired. I mean, these Monday, Tuesday, Wednesday, Thursday, Friday classes, plus 2-day classes, 3-day classes, as a matter of fact, taking a toll on me, or has taken a toll on me. So I just need some time for myself to recoup. So please complete your Educasoft. Any other question? If not, ciao.
I found the 2019 paper which you did a question from. So I'll share it in the WhatsApp group.
Great. Big up yourself. Yeah, man. And then we can work through the other questions. All right, guys. Thanks for coming out as per usual. We'll talk.
Have a good one.
To you too.
Big up yourself, sir.
Yeah, man. Big up yourself, puppy. To be glorified.